Welcome back to PDP demos. So you might have seen the previous demo, which was concerning very small files and web development, nice GUI-based retrieval. This one's going to be focused a bit more on large files and public datasets. So what we're going to do here as a PDP SP, we're going to be storing big, cool public file and putting it on PDP and getting proofs storage for the file. There's a lot of applications for this sort of thing in the very immediate sense. For example, running the Filecoin network. It would be very nice to do this sort of thing with the snapshots and with various other critical network infrastructure data like the proving parameters or the trusted setup information. But today we're not going to talk about any of that stuff. We're going to talk about fun, new, exciting things. We're going to be talking about OpenAI, or rather the most open AI that we have. So we got R1 670 billion parameters down here. And if you go to Hugging Face, you can just download this. It's an open weight model, and that's really cool. So I don't have all the commands because my terminal history dies, but you can download things really fast with Hugging Face's Python CLI, and that's great. So we did that, and now we have this file. Let's make this bigger. It's like 650 gigs. I recently ran compression over this, and we ended up getting 531 gigs. Cool. So that's what we care about. This file, R1 archives, tar.gz. Sweet. Okay, so now let's set up a PDP proof set for this public data. As a PDP SP, maybe somebody is paying me to do this, or maybe, I don't know, I could be doing this for some sort of decentralized protocol, data DAO. There's a lot of different possibilities. But regardless, let's assume that there's some reason that you want to do it. And maybe you just love big language models. So what's the first thing we need to do? Well, we need to create a proof set for ourselves to store this data. We really don't want to mix it up with other stuff like our cool image proof set from the previous tutorial. So let's make a proof set. So this PDP tool has the ability to do that. We want to make sure that this is the correct thing. This is the PDP service, which will be making sure that the proofs are good and will be hooked up to the Explorer. And so we started creation. Now what we do with the PDP tool is get proof set, create status. Yep. And we give it this TX. And then we can go watch on that. And then we can wait. So while we're waiting, a nice fact is that Curio upload is unrelated to Curio commands. So if you want to create a command that goes to the chain, adding a root to a proof set, or actually doing your proof, or creating a proof set like this, that's all fine and good, but you don't actually need your proof set ID to actually upload the file. Let's go back there. We can get started on the long, arduous process of uploading our big file. The standard API, which keeps track of everything, and I think probably is the best you can do. You need to send things over the network. So we're going to upload, in this case, we're going to upload R1 archive, tar.gz. Okay. And this is going to take a long time, but it's something convenient to kick off while we wait for our other process. So we'll let that do its thing for a while. So this is like 530 gigs. So what it's going to be doing is chunking this tar file into 200 megabyte chunks, sending them over the Curio API, uploading. So what this is doing is chunking this file, and it's sending those over the API. And it's going to be grouping things together. So this is going to be chunking things into those small chunks, and it's actually also going to be grouping things together into 64 gigabyte chunks, because the way Curio works, that's the limits for the root size today. It's not a PDP protocol thing. We can make that up to like many petabytes, honestly, which would be a bit crazy, but you could do it. We're today limited to the max sector size, just based on some of the libraries we're using to do data preparation sort of stuff. So that's fine. This is reminding me the output of upload file is pretty important. It should actually be something we redirect to a file because it's something that we need to send into another command, the PDP tool add routes command. So what I'm going to do is actually stop this, which is fine because it actually can detect the things that it's already uploaded. So then I'm going to go pipe this to, we're going to say R1 upload, and then we can just watch. As you can see, it's going a lot faster this time around because we've already done a lot of the uploading. Okay, but at this point, we should be able to go back and see that, yes, we have created a proof set. And in fact, we have. And now we'll just go to our PDP Explorer and we'll check that out. But we can check out the latest that's happened on this proof set. And we can go to the verifier itself, which is at this address. And we can look and see, yeah, so this looks like a proof set create message because we have this Sybil fee. That's going to actually set me back quite a bit. My sender address is losing out on a lot of funds based on that. But we should still be good for a few more days. It's pretty cheap to prove PDP, but creating a proof set incurs a decent little cost just as a Sybil prevention mechanism. Okay, fine. Need a little bit more fill. So we're continuing to upload. That's all good. After we're finished uploading, then the proof is going to kick up. So there will be like a proving period every day. So we'll also have to come back in even more time to show the proof actually landing. And I'll show a download as well after the upload happens. But for now, I think we're just waiting on the proof set creation to trickle its way into the Explorer. We're back after a long delay. So you can see that we have uploaded the file. How can you see that? Well, if we take a look at the R1 upload out, this is the output of the upload file command. What you see are paragraphs of different chunks of data, each one corresponding to 64 gigabytes. Every one has a piece index, I guess you could call it a root index, and each one consists of a bunch of CIDs of all of the 200 megabyte chunks. So each one of these CIDs is a 200 megabyte chunk that was uploaded across the API. And then the very first one is the root, which will actually be put on chain. So if you go to the very first root, I actually already uploaded. So everything is uploaded. The next thing to do is to go and add these to the proof set on chain. So let me show you the first one. This should already be added on chain, which I did to kick off the proving process. So let's just make sure. So we have piece 1. What we want to do is go back to piece 0. So piece 0 ends with CHUYI, and I've uploaded it right here. So this is 64 gigs. It's the aggregate of all these pieces, and just the root is on chain. By putting it on chain, kicked off proving, and you can see I've waited a little bit in between. So we had a proof yesterday, and we're about to have another one today. After we added the roots, we ran next proving period, which kicks off the beginning of the first proving period, and then we get our first proof a day later. So that's that. I'm going to add the rest of the roots now. Right now we only have one root, and the way I'm going to do that is by taking all of these paragraphs, which are just inputs to the add root command in the PDP tool, and passing them to the PDP tool. So I've got a nice little shell thing over here, which should work just based on previously doing things. So let's refresh. Back to proof set 3. Not seeing any roots yet, but if we go to Filefox, then we can probably see on the contract So we have pending messages, and that'll trickle its way to the Explorer eventually. Now that we have added our data to our proof set, the next thing I'd like to show you is retrieval. So we'll get out of Bash. We've added to our proof set, and regardless of whether the data is actually added to the proof set or not, you can retrieve from Curio as long as it's been uploaded. So retrieval is actually good to go. One thing I neglected to do earlier when I was uploading was specify this chunk file parameter. The UX is still being kind of figured out. We have this specification of the output that we just use to send to the add routes. The output of upload file just gives you a text sequence, which you can just copy and paste and throw into add routes as the input for the route parameter. Just did that to make things as simple as possible. But on the retrieval side, we really don't care about how we're grouping things up inside of these routes. What we really want is just like a manifest of all of the CIDs. So if you specify this chunk file thing, when you upload a file, then it will actually write to this guy all of the CIDs that you're chunking, just in an ordered list so that you can reconstruct your file by fetching every CID. The individual pieces, which are aggregated together into the root, are the units which are retrievable from the Curio HTTP API. So they're the things that we care about, not the sub-aggregations, the 64 gig things that we're adding to the PDP proof set. Okay. All that said, what we can do when we upload is specify that we want to write these CIDs to the file. Thankfully, we have this nice dry run flag, which we can use to not upload anything, but simply do the hashing and quickly output all of our CIDs. It still took a long time because it was 0.5 terabyte and I don't have it parallelized yet, but we have that manifest now. I wrote it all into R1.retrieval. If you see this, you can see we have a nice bunch of CIDs, which is great. So the reason that you want to have this manifest is the PDP tool can actually download files, and it does so with this chunk file specified. So what we want to do is go to R1 retrieval, and then go to output file, and then we can go to, we'll just call this R1 all.round trip, the whole model, and we can run this. And if you spell things wrong, then it won't work, which I guess is a good thing. Retrieval. Okay. And I have disk roots. It's fine. Yeah, you don't need to specify proof set or anything because Curio just has a big API of all of its pieces. It's like a big bucket for pieces. I do have enough disk space to have everything 3 times now on my machine because I first uploaded it and then Curio stored it in its own place, and then I downloaded it here. We can see that downloading has started. Okay, and it's saying it's going to take 4 hours. It's going to take a while, so I'll have to come back to this. But yeah, this is how you download a file, and it can be a really big file. It can be, hundreds of gigabytes or terabytes, and it will just work. It'll take a while. As long as your Curio API is available, you can just retrieve the pieces, and then they'll be reconstructed and streamed to disk using this command, and everything should work. So again, after a long delay, we're back, and after all this time, we've successfully completed the download of our file using the PDP tool. I'll show you that we have the correct file by using a hash over this and over the original. We can thank the good people behind Blake 3 for a very fast hash function which will saturate all of our cores. And this is just the output of running PDP tool download file. The other thing that we didn't have and that we now have is confirmation on the PDP Explorer that all of the files have been added. So you see we have 864 gigabyte files and 122 gigabyte files. This is all of the archive of the R1 model parameters, and you can see that it's being proven actively. we can take a look at that message. And if we want, we can even confirm the Merkle tree of some random selection of 32-byte chunks of this file. So we are proving to the chain that we have possession of the R1 model parameters. Great. So it'll take a while to finish B3 sum, even with all of our cores being saturated. In the meantime, I guess I can point out, so PDP tool, download file. So all this is really doing under the hood is going to the Curio API. If we look at the code, we see that we're just requesting over the Curio API. And something I can show you is that we can just do this directly in our browser too, to retrieve. If you saw the other demo, you saw that in proof set 0, you have a bunch of images, which are much more appropriate to download through your browser than these huge 64 gig chunks. So all you have to do is go to the Curio endpoint, and this node is at paintedprocedures.com, and it should work to just go /piece/this. And this should be enough to download our file. Great. We get download. And there we go. We got a cat picture. So with the download file command that we just ran and waited for a long time to work, we just did that a bunch of times for all these chunks, which are under 200 megabytes. Okay. And unfortunately, this is still taking a little bit of time. I did actually do it before I turned on the videos sharing. So you can see that they actually have the same hash. It looks like we might be done given. No, these are still full of like 3. But if you trust that I'm not playing any funky games, then you can see that these files round trip the same. So retrieval works. So overall, that's the demo of CLI Curio operations and storing R1 on PDP. Brief recap. You can create a proof set from the CLI. You can add data. We have some nice convenience methods like the upload file method. And oh, nice, it completed. And you can see that I wasn't lying. These are the same. Nice. But yeah, we have PDP tool. We have upload file, which uploads large files in chunks. If you have really small files, you can just use upload piece, which we didn't cover, but it's pretty simple. Prepare piece just as hashing on that piece. We can also download files using the Curio API, or we can just directly hit the HTTP API like we just did with this nice cat. We can create proof sets, and there's some utilities for interacting with them. We can add roots, which we also did when we had finished uploading the file. We added a bunch of the roots in order to actually get the R1 data onto the chain so that it would be proven. You can also remove roots. Thanks very much for watching.